We saw how can we create different blocks of errors or the exception using the try and except block. How can we combine multiple exception types into one block, as well as we also saw how can we use else and the finally block. But everywhere it was Python who was raising an exception. But can we raise an exception? So the answer is yes. But what is the raising an exception means? It means that manually raising an exception instead of depending on the interpreter. So for raising an exception, we have to use a raise keyword and the type of error or the class of the error which we want to raise, and the message that we want to should display to the user should be passed as a value to that class. So let's see an example of this. Instead of depending on the interpreter to check whether the denominator value is 0 or not and then raise an exception, let's handle it ourselves. So here we can say if number 2 is equal to 0, we want to raise a 0 division error, and the message that we want to pass inside is you have entered number 2, denominator cannot be 0. Let's put it on a new line. So here let's put slash n, and here instead of having this print statement, let's comment this out and let's make this part as VE, since we are creating an alias, and we are going to print that VE over here. Now let's see the output of this program. Let's execute our program. Python raise error. Now let's enter 12 and let's say we provide 0 over here. Here you can see that it has properly now printed the raised message, which was you have entered 0, denominator cannot be 0. And then it went into the final block. So this is how you can raise an exception for certain conditions and then catch them in a exception block. Now here we will have to be really careful when we are raising an exception. If the block in which this exception has been raised is not handling that exception, then that exception will be raised onto the section of the code which has called the current block. Like let's say we have a function, let's give this function name as func a, which is accepting one number, then it's going to print in function a, and it's going to call function b, where we are going to pass this number, and it's going to call the print statement ending function a. Now let's define function b. Func b is again going to accept the number, print inside function b func c, which is going to accept this number. Then we will have print ending function b. Let's define function c, say tag func underscore c, which is going to accept a number, then print inside function c, then if number is less than 0, raise value error, let's say number cannot be less than 0. then we print the number, print ending function C. Let's ask user to enter a number, and we are expecting it to be an integer number. So enter a number, and then we are going to call function A by passing that number. Let's see the output of this program. Let's run our program. Error, escalation. Let's enter 0. And here we can see that it has went inside function A first, then it called inside function, it went inside a function B, then function C. It's printing that number, then it prints ending function C, function B, function A. So as the sequence in which the calls were given, the output has been in the same sequence. Now let's run again, and this time let's give -223 as a value. So here we can see that as soon as it went inside function C, it raised an exception. And since there was nothing that was catching this exception in function C, B, or A, it gave that exception or the error to the interpreter, and interpreter has handled it. And hence we got the entire trace back. Now let's handle this exception outside of function A, B, and C. Let's say we provide here try. Function A is inside it. Since the raised error will be a value error, hence we are going to put accept value error as VE, print VE. Let's see the output of this program. Let's run a program, Python error escalation. Now let's enter again -12. And here we can see that now the exception has got handled, and it has just given us a single message which we provided in a raise statement instead of interpreter giving us the entire trace back. Let's say we also want to handle an exception in the function A itself. So we can say try, then accept value error as VE, then print VE. Now let's run this program and see the output. Python error escalation. Let's enter -12 again. Now this time we can see that it has went inside function A, function B, and function C, and as soon as there was an exception or the error which was raised, it went back to function B, which then raised it to function A. And since there is a try block which is basically to handle the exceptions in function A, the function A has handled the exception and it prints number cannot be less than 0 and then ending function A. Whereas in earlier case there was in function A, inside function B, function C, and then there was just an exception because there was nothing which was handling the exception in function A, function B, or function C. It was outside of the function A, B, and C, and hence the ending function A part or function B or function C was not printed. Now let's see if we put the same thing in function B. Now let's put the try except block inside function B. So when it calls, we want to get an exception. Now this time also we are going to catch the value error. Let's print it VE. Now let's execute our program and see the output. Python error escalation. Let's again provide -23. Now here again, now you can see that it went inside function A, then function B, and function C. In function C, we raised an exception of value error which says number cannot be less than 0, which was then raised back to the function B. And since function B now has the try except block, it caught it, processed it, and then after printing the actual processed message, it went on printing the print statement which is present inside function B and function A. Now let's add the try except block in function C as well. Now let's add the try except block here. Let's say try, and we are going to put this code inside the try except block, and then we have except, which raises a value error as VE and print that VE. Let's execute this code and see its output. Python error escalation. Let's enter some negative number now. So here we can see that this time also it went inside function A, function B, function C. And since function C raised an exception and it is processed over there, it has printed that number cannot be less than 0 message. And then it prints function C, function ending function C, ending function B, and ending function A. Here we can see that when we raise an exception, if we have a try except block within that same function, the raised exception will be processed. If it is not present, it will be sent back to the function which is called the current function where we have raised an exception. If that function has handled it, with the try block, it will handle the exception and process it. Otherwise, it will be raised back to the function or the block of code which has called this new function. So this way we can see that the exception raised will get processed depending on where it has been handled, and it goes sequentially till it doesn't find any exception handled. If it doesn't find any exception handled in our code, it will raise it to the interpreter, and an interpreter will raise that exception with the entire trace back.